Hi, my name is Adriana Alvarez.
Hi, my name is Pablo Castillo.
And we're going to teach you how to jumpstart a car.
Check the tire pressure.
And check the oil level.
Hi, I'm Pavel's mom, and I'm here to supervise.
Open up the hood, then find the lever and be able to open up the hood and place the placeholder into its position as shown here.
So you're going to want to find the dipstick, which is an orange cap right here. Take it out using a towel. What you're going to do is you're going to take off all of the excess oil as shown here, cleaning it off. After cleaning off the dipstick, you're going to want to place it back to where it's supposed to be, inserting it in very carefully so that it doesn't bend or anything, like almost what I did right there. You're going to want to put it all the way in, then take it out, and then see the measurement. Now you're going to look for the little black mark. If the oil is above that black mark, that means your oil is good. If it's below it, that means you need an oil change.
Now place the placeholder back into its original position as shown here, and then gently let it go. Now to check the pressure of the tire, we need to see the operational pressure of the tire that is being used, which as shown below is 33.
So now we get our air pressure gauge, which measures the air pressure in a tire. You stick it into the air cap, right like that, and make sure it's all the way in so you get the correct amount. Now we have a little slider, so now it will measure the ruler, and we have 32 psi for this tire. The same process for the other tire, we're going to do for this tire. So we put it into the air cap, make sure it's in all the way, the ruler sticks out, and now we measure the psi. In this tire we have about 33 psi, which is exactly what we wanted. That's the optimal amount of pressure in a tire that we should have. So now we're going to show you how to jumpstart a car. You're going to need your wire cables. These cables come in red and black. You need two cars with two separate batteries. You're going to need an auxiliary car, one that will charge the other one, and a dead car. So now there's a positive and a negative side to each battery. One in that car, and in this car, positive and negative. Positive will be in red, negative will be in black. You're going to get your positive cable and you're going to attach it to the positive side of one battery, as shown right here. Clamp it there. Set. Now you're going to get your black cable on one of the sides and clamp it to the black side of the other of your battery. Now we're going to go to the other car, get your red cable, and very carefully clamp it down to the positive side on that car. And then get your negative or your black side and clamp it down to the black end of the other cable. So now we got our two cars represented by the dead one here, the blue one, and we got our auxiliary, the working one here, represented by the black Nissan. So now you get your auxiliary car and you start it up, just like that. Then the electricity should flow from the auxiliary car to the dead battery of the blue car, and that'll start it up.
Now what you can do is take off the clamps and make sure they don't touch each other as shown here, and then take off the clamps here once again from the auxiliary car.
So the physics of how to jumpstart a car. Now we have two different batteries. We have the dead car battery that we need to pass the electric current to, and the auxiliary car battery, which is the one that's going to transfer the electrons to the dead car battery. So what happens is that we attach the cables from the positive side to the positive side and the negative side to the negative side. Now the negative side of the battery is attached to the base of the car. So the one that's going to do the passing of most of the electrons are the positive ones. So what happens is that electrons move from the negative terminal, which is here, represented by these little circles, to the other negative terminal. So from the auxiliary, when you started, electrons move to the negative side and then go to the base of the car. Once it goes to the base of the car, those are connected to the positive terminal, and the positive terminals send electrons to the positive side, and it makes a round circuit. It is called the closed circuit. In this closed circuit, we have the auxiliary car battery cycling through electrons from the positive side, going through the base. Then since the negative side is attached to the base, it sends its electrons back to the base of the dead car battery, and then you make a closed circuit which eventually powers up the dead car battery. Since the auxiliary car battery is passing its electrons from the positive side to the negative side, from the base of the car, passing it over to the negative base, or to the negative side of this, of the dead car battery, which is the base of it, and then traveling through the car, eventually hitting the positive side, and then you have a roundabout system, which is a closed circuit, which eventually ends up starting the dead car battery.
I'm going to explain the physics behind checking the tire pressure and why it's always best for you to check it when it's a cold tire than when it's a hot tire. So the answer lies in simple physics. So warm air expands and cold air compresses. Therefore, when the air in your tire is cold, it will read a lower PSI. This is because the temperature of the tire is cool, meaning the speed of the gas particles in the tire is slow, so the tire compresses to its normal size. The particles are not moving as fast. Okay. However, when it's a hot tire, it will read a higher PSI because the warm temperature speed of the kinetic energy of the gas particles in the tire, and thus it would expand, getting you a wrong PSI reading. As you can see, the molecules are super like all over the place. So in a hot tire, as said here, it would expand, and in a cold tire, it wouldn't expand as much. It would compress back to its normal size. So moral of the story, when trying to check your tire pressure, always check it when it's a cold tire than when it's a hot tire. Boom. Will someone explain the physics of voltage when passing current with another car? When passing current from the auxiliary battery to the dead car battery, both batteries must be of the same voltage. This is due to the voltage formula V equals IR, also known as V equals current times resistance. If the voltage of the battery of one car is 6 volts and the other is 12 volts, then the car with 12 volts, we need a car with a battery of the same amount of volts that this one has, I guess, yeah, to pass current. Anything above 12, so if it's 13, would not be able to work because it would pass too much current and destroy the electrical components of the car. Anything less, such as 6 volts here, will not pass the sufficient current needed to start the dead battery. Also, the car with less voltage will have less resistance than not being able to take a high voltage charge.
And we're signing off. My name is Pablo Castillo.
And my name is Adriana Alvarez.
Bye.
Bye.